Here we are solving June 2022 Pure Math 4 paper. In part 1 we have completed question number 1 to 3. Now let's look at question number 4. This is implicit differentiation. You need to differentiate it and make dy by dx as a subject. So how do we differentiate it? Just differentiate everything. 16x cubed becomes 16 times 3x squared minus, you have 9k x square y. Okay, I'm gonna keep 9k as it is. You have x square y. Derivative of x square is 2x, derivative of y is 1. So apply the product rule here. Keep x square as it is, derivative of y is 1, but you need to put dy by dx whenever you differentiate y. Plus, keep y as it is, derivative of x square is 2x. That's how you apply product rule. Plus, when you differentiate 8y cubed, 8 3s are 24. 24y square is equal to 875 becomes 0. I can see there is a common factor for every term, so divide by 3. So this 3 will be gone, this becomes 3, this becomes 8. And we need to make dy by dx as a subject. I'm going to open the bracket first. But here, when we differentiate, we should have put dy by dx with it. Is equal to 0. Okay, now we have 16 x squared minus 9x squared dy by dx, not minus 9, minus 3. It's not 9, it's 3. We divided everything by 3. Minus, when you multiply 3 by this, you will get minus, there is a k also. 3kx squared. You need to be very careful actually. Always compare here whether you are getting this answer. 3k minus 6kxy plus 8y squared dy over dx is equal to 0. I'm gonna make dy by dx as a subject now. There are two terms with dy by dx. Take dy by dx as a common factor out. So I will get 8y squared minus 3kx squared dy over dx is equal to, bring this term and this term to the other side of the equation. This becomes positive 6kxy, negative 16k square. We got the answer already. Therefore, dy by dx is 6kxy minus 16x squared divided by 8y squared minus 3kx squared. That's all. That's the answer. It's a 4-mark question. Part B now. Given that the curve has a turning point at x is equal to 5 over 2. What does that mean? The x coordinate of the turning point is 5 over 2. We don't know the y coordinate. Find the value of k. Okay, we are going to take dy by dx from the previous part. We got dy by dx as 6kxy. 6kxy minus 16x squared divided by 16x squared divided by 8y squared minus 8y squared minus 3kx squared. That's from the part A. Now, when the curve has a turning point at x is equal to 5 over 2, when you sub in x is equal to 5 over 2 here, the dy by dx becomes 0. So you write dy over dx is equal to 0, x is equal to 5 over 2 implies, replace x by 5 over 2, 6ky times 5 over 2 minus 16 times 5 over 2 whole square divided by 8y square minus 3k times 5 over 2 whole square is equal to dy by dx is 0. So straight away bring the denominator here, it becomes 0. So what we have here is 3k, 3 times 5 is 15ky minus 2 square is 4. When you cancel this, you will get 4 times 5 square. 5 square is 25. 4 times 25 is 100 is equal to 0. We need to find the value of k, but there are two unknowns here. So there is no way we can find the value of k here. So what are we going to do? We are going to find the value of y here in terms of k. You will get 100 over 15k. Y is equal to 100 over 15k. which is, if you cancel, put it in your calculator, you'll get 100 over 15 is 25 is 100, 353k. That's y. That's the y coordinate of the turning point. So since this stationary point lies on the curve, sub in this stationary point the x and y values into the original function and make k as a subject. Okay, I have taken the function and the point here. Now I'm going to sub in the point here. 16 times x cubed minus 9k x squared times y plus 8y cubed 20 over 3k whole cubed. Put the 875 also this side is equal to 0. Now we need to carefully simplify this. 16 times 5 over 2 whole cube. 16 times 5 over 2 whole cubed is 250. This is 250 minus, we can cancel this k and k, and then I'm going to simplify the rest of the things now using my calculator. 9 times 5 over 2 whole square, which is 25 over 4 times 20 over 3, 375. So it's 375, and we have minus 875 plus this one, 8 times this cubed, 8 times 20 over 3 whole cubed. Oh, okay, 64000 divided by 27, and there is k also is equal to 0. Now simplify these numbers first. We have 250 minus 375, 250 minus 375 minus 875. We get minus 1000, goes to the other side, becomes positive 1000. We have 64,000 divided by 27, 1 over k cube. So basically you can cancel, divide both sides by 1000. So 1 over k cube is going to be 27 over 64. Flip both sides, k cube is 64 over 27. K will be cube root of 64 is 4, cube root of 27 is 3. 4 over 3 is the answer. That's all. Question number 5 now. It's integral substitution method, u substitution. We have the substitution given. Usually it will be given as u is equal to something. Here it's given as x is equal to 2 sine u. Okay. Anyway, it doesn't matter. We need to just change everything in terms of everything here. All the x's in terms of u and the limits also. Okay. So I have taken the integral and the substitution here separately. So we are going to carefully change everything in terms of u. So replace x by 2 sine u. You will get 3 times 2 sine u is 6 sine u plus 2 divided by 4 minus x square. When you square this, it becomes 4 sine square u to the power 3 over 2. We have changed everything already. We need to change dx and the limits now. First, when you differentiate dx over with respect to u, you will get 2 cos u. So dx is equal to 2 cos u du. So I'm going to replace dx by 2 cos u du. That's over. How about the limits now? X is equal to, x, and u is, when you make u as a subject here, x over 2 is sine u. So u would be sine inverse of x over 2. So when you replace the lower limit 0, sine inverse of 0 is 0. When you replace upper limit 1, sine inverse of half. Sine inverse of half is pi over 6. So the limit is 0 to pi over 6. So we have converted everything in terms of u already. Now the next step, here I'm going to take 4 as a common factor. So it will come out with the power 4 power 3 over 2. Inside you have 1 minus sine square power 3 over 2. The numerator stays the same, plus 2 cos u, not plus, times 2 cos u du. Integral 0 to pi over 6. Now in the next step, I'm going to replace the 1 minus sine square by cos square. This becomes cos square. So you will get cos square x power 3 over 2. When you multiply the powers, it becomes cos cube. And 4 power 3 over 2, use your calculator. 4 power 3 over 2 is basically 8. So we'll get 8 cos cube u, 6 sine u plus 2, 2 cos u du, 0 to pi over 6. We can cancel 1 cos u here, it becomes cos square. Cancel this, becomes 4. And from the numerator I'm going to take out a common denominator, common factor as 2. So we will have 2 divided by 4 integral 3 sine u plus 1 divided by cos square u du. 2 over 4 is basically 1 over 2. And then split this. Split this into 3 sine u over cos square plus 1 over cos square. So we will get 1 over 2 outside. 3 sine u over cos square u plus 1 over cos square u du. I think we almost got the answer. So sine over cos square, you can split it as sine over cos times 1 over cos. Split the cos square into cos times cos. Sine over cos is tan, you will get tan u. 1 over cos is secant u. That means we got the answer already. Multiply throughout by 1 over 2. We get 0 to pi over 6. 1 over 2 secant u tan u plus 1 over 2 secant square u d. That's all. So here p is equal to pi over 6. That's all. It's a 4-mark question. Let's move on to part B now. Part B, they want us to integrate the original function. We have rewritten this in this form. 0 to pi over 6. 3 over 2 secant u tan u plus 1 over 2 secant square u du. Integrate it. Integral of secant u tan u is just secant u plus 1 over 2. Integral of secant square is just tan u. Sub in the limits. You need to carefully sub in the limit. When you sub in the upper limit, 3 over 2 secant pi over 6, which is same as 1 over cos pi over 6, plus 1 over 2 tan pi over 6, minus 3 over 2 secant 0 plus 1 over 2 tan 0. Cos pi over 6 first. Cos pi over 6 is root 3 over 2. So secant would be the reciprocal of it, 2 over root 3. So here 3 over 2 times 1 over our answer. 1 over answer is 2 root 3 by 3. That would be the secant, because secant is 1 over cos, right? Plus half tan pi over 6. Tan pi over 6 is root 3 by 3. Root 3 by 3. That's the upper limit. Minus, let's sub in the lower limit. 1 by cos 0. Cos 0 is 1. So secant 0 is also 1. So it's just 3 over 2 plus tan 0. Tan 0 is 0. So we need to simplify this. Simplify the like terms now. Let's carefully simplify the like terms. You'll get the common denominator is 6. So 7 root 3 divided by 6 minus 3 over 2. or if you multiply and divide this by 3 to make it a common denominator will be 6. You will get 7 root 3 minus 9. That's the exact value of this integral. Question number 6 now. We have 3 points, position vector of 3 points A, B, C. The line passes through point A and B. Find the vector equation. First you need to find the AB vector. AB vector, always remember is this rule. It's OB minus OA. OB is this 5, 3 minus 2 minus OA 1 minus 4, 3. So you'll get 5 minus 4, 5 minus 1, 3 plus 4 minus 2 minus 3. You got AB vector. Now you can straight away write the equation of L. R is equal to, use any one of this vector, up to you which one you want to use. I'm going to use the first one. You can use OB also if you want. Plus lambda times the AB vector. That's how we write the vector equation of a line passing through 2 points. Let's move on to part B now. Part B says, given that AC is perpendicular to L. Okay, we have a line L and we know point A lies on L. Now there is another point C. This AC is perpendicular to L. Did they say C lies on the line? No. We have the position vector of C here. So what we need to do, we need to write, so if two vectors are perpendicular, AC vector dot the line. So you need to take the direction vector of the line, which is this 4, 7 minus 5. So dot 4, 7 minus 5, since these two are perpendicular, this will be equal to 0. So we need to find AC vector. AC vector is basically OC vector minus OA vector. Let's take the position vector from here. OC is 3p minus 1, 3p minus 1, minus OA is 1 minus 4, 3, 1 minus 4, 3. So it's going to be 2p plus 4 minus 4. Now let's put this vector dot this vector is equal to 0. So 2p plus 4 minus 4, because that's a condition for perpendicular vectors. A dot B is 0, the dot product of these two. So 2 times 4, multiply the corresponding elements. 2 times 4, 7 times p plus 4, minus 4 times minus 5 is equal to 0. Make p as a subject. So it's going to be 8 plus 7p plus 28 plus 20 is 0. So 7p will be equal to 4856. So p is, minus 56, p is minus 8. That's all. That's how we find the value of p. Let's move on to the next part, part C. Hence find the area of the triangle ABC. Okay. We have the line with 2 points A and B. There is another point C here where AC is perpendicular. Now they want us to find the area of this triangle. It's a right angle triangle. The base is AB, the height is AC. So let's find the modulus of AB vector. We have calculated AB vector here already. AB vector is 4, 7 minus 5. So modulus will be square root of 4 square plus 7 square plus minus 5 whole square, or just 5 square. Square root of 4 square plus 7 square plus 5 square. 3 root of 10. Now modulus AC vector, square root of AC vector is here. You just need to sub in the value of p here, that's it. So it becomes minus 4. 2 minus 4 minus 4. So 2 square, 4 square, 4 square. You will get 2 square, 4 square, 2 square, what I'm writing? Square root of 2 square, 4 square, 4 square. Just 6. So now the area of the triangle is equal to half base times height. So you will get 9 root of 10 square units. That's all.